Thank you. So my name is William, and I'm going to talk about an implementation of the Debs challenge running on Apache Geode. So first things first, so if you're not familiar with Debs, it's the Distributed Event-Based Systems Conference hosted by ACM. Every year they post grand challenges, and for 2015 they tried to post a challenge about analyzing taxi trip information that was available for the New York taxis in 2013. And the data set is actually small, but the idea is that you can implement this architecture and then, of course, scale that for really big data. And they're pretty much asking two questions. So they want to know the most profitable areas and the most frequent routes. You can think of Debs like this, because the taxi drivers, of course, may have some special interest with them. And another way to kind of summarize here what is Geode. So Geode is an open source project donated to ASF. It's currently incubating. And the main concept here for a Geode system, so there is a cache, a region, and a member. So a cache you can configure to XML or Spring or Java. A region you can think of it as a map on asteroids, a hash map with a key value store. It can be redundant, highly available, so distributed in all the nodes in the cluster. We have different kinds of members, so locator, servers, and clients, where the locator is kind of a load balancer of some kind. And of course, you can then do a lot of things with them, including query data using OQL, which is a way to query objects. So if you're not familiar with the project, so previously it's also known as a commercial product named Gemfire, and these are some of our use cases or case studies that we have published on the website if you want to know like what it's actually doing. So pretty impressive numbers there. So how we actually implemented that challenge, right? So we are leveraging these three main parts of Geode. So one is PDX, which is our own serialization mechanism. The idea of functions, which is a way to deploy Java code and have the code executed in a cluster in a distributed way with failover and everything. And then we have a bunch of different callbacks, which you can also use to intercept data and then do something with data. Do, for example, an async event listener, which is a way to batch and work on some windows of time to deal with data, do some processing, for example, which can be parallel or serial depending on your needs. So just to compare a little bit, PDX with Avro or Protobuf or anything else. So PDX is right here. And you have another way to do it called auto-serialization as well. So the performance is very good. And the other reason that it's very interesting is because it allows you to have, for example, different versions of the same object in the cluster. And we keep a registry of that structure of the data in the cluster, right? And then if a new client, for example, connects to the system and asks for that object, if that client, for example, is from an older version of the system, the system in Geode is smart enough to not send the objects, for example, that client might not know. So it's a good way to actually evolve your structure, your data structure, without actually having to update all your clients. The idea of the async event listener, right? So it can be parallel and serial, and the idea is that every node in the cluster will have a small queue, and this queue is also distributed, and you can set a bunch of specific settings here for the queue, like if you want to do that by batch size or by batch interval or something like that. And then inside that listener, what you can do, the programming model is very simple too. So you are iterating over the events for that specific time or size. And then you can pick up like only the fields you're going to use for the computation. So you don't need to deserialize the entire object in order to do some computation here. Overall, this is the architecture we end up doing. So we have a client that is sending some text information to the cluster. The data is distributed and hashed. And with that, we have one region that receives all that data, and then we have a bunch of listeners then are monitoring the data there based on that batch that we are specifying, and then we are performing some kind of SQL here, which is actually OQL. So we are monitoring all the taxi trips, and we are counting the average or the amount of fare trips that we have there. And then by that, we pretty much get the top 10, and then we update a client, right? That's kind of one of the queries that Debs challenge has to implement. We have the other two, and the source code will actually be available on GitHub. Just to make a call for action here, please join our communities. We are currently incubating. Some references, if you're interested in the photos of the taxi drivers too, they are from here. Thank you very much.
Thank you, William. Okay, if not, we'll close down the lightning talk session. Thank you.